Hey guys, we are back again and we're going to look at the last stage of the data analysis for your catalase lab. So before we do anything else, it's probably a good idea to go back to our original question. We want to ask or figure out what the optimal temperature for the decomposition or breakdown of hydrogen peroxide by catalase, which we got from Saccharomyces cerevisiae. So remember, we're breaking hydrogen peroxide down into water and oxygen gas, and the enzyme we're using is catalase. We varied the temperatures and measured the amount of oxygen produced. And so now we really want to look at what that looks like in a graph. So in a previous video, we went through and we looked at the data. So we had at each different level the percent produced, and then we got the mean at each time point and calculated standard deviation. We graphed those, but now we want to get a graph that looks something like this. We really want to figure out the optimum temperature, which would be the peak of that graph. And so in order to do that, we need to have a reaction rate versus temperature. So we've already done a oxygen gas versus time graph, and we looked at the slope of each of those lines to get a general idea of what the reaction rate for each of those is, because that's basically O2 versus time. However, in the most recent subject report, so 2019, and these are put out by International Baccalaureate, basically saying things that they noticed were being done in IAs that were incorrect. One of the things they said were there are examples of candidates calculating mean rates by averaging the data for all the trial runs and then calculating the mean from this, which is exactly what I told you to do. This is inexact. The rate for each run needs to be calculated and then the mean from all the rates. So that's what we're going to do. If we look at rate, it's just the change over time. So in this particular case, if you measured percent oxygen, we're looking at the change in percent oxygen over the total amount of time. So here that's the final O2 minus initial O2 divided by final time over initial time. And your unit is going to be percent oxygen gas produced per second. So let's go to the data. So here we have our practice data. Instead of just figuring out the rate based on your mean values, what we're going to do is calculate rate for each of your trials, and then from that, get the average of those values. And I still have that other graph up, so we can go kind of look at that and do a comparison. So if I click, I'm going to make a rate space. I'm going to click here, and I'm going to do some math. So here I'm going to hit equals. And now what I want to do is tell it exactly what I want. So I'm going to put in parentheses, I want to do my final, which is this B11 cell, so I can just click on the cell, minus my initial O2 value, which is here, and then close parentheses. And then I want to divide it by the total amount of time elapsed, or the final minus initial, which in this case is 120 seconds. So I'm just going to do divided by 120. If I hit equals, it's going to give me a value. And based on what I saw in my graph, that's a reasonable value for this. You always kind of want to ask yourself, does that number make sense? Does that seem like a reasonable amount of oxygen gas produced per second based on the numbers that I'm seeing here? Then we can do our trick and pull this over, and it will do that for all of these. I always like to click on it to make sure it's actually doing what I want. So here I want my final, which is the C11, minus my initial, which is the C3, okay, and then I want all of that divided by 120. So it did actually understand what I wanted it to do. It's always a good idea to check those things. Here, now I'm going to hit equals, and I want to get the average of these three values. So I'm going to say average equals average. If I click on that, and then I'm going to select the data that I want it to average and hit enter. And then again, I'm going to look at that and see if that's a reasonable average of those values. So I have 0.009, 0.001, 0.004. That is a reasonable number, so it is doing what I want it to do. If I compare that, so for 27 degrees, if I go here and I look at my mean here, that's 0.006 is what I get if I'm just looking at the slope for my 27 degrees, which is right here. And so IB is correct. This is a better value. So here, just to see what I did again, you're going to do equals, and then I'm going to tell it what I want it to do. So I'm going to put parentheses because I want it to do the order. This value minus this value, so my final minus my initial, divided by final minus initial time, which in this case is 120. Again, equals, and it's going to give me a value, and yeah, that looks reasonable based on that data. And I'm going to drag, and then I'm going to get my average. So again, equals average or mean value, and it knows what I want. I'm going to check to make sure it's doing the right thing, and hit enter. I've already adjusted it to have this number of decimal places. If you get stuck on that, we can figure out how to do it together in class. I went ahead and did all of these, so I went through and did those calculations. And then I put them in a table with the temperature and reaction rate. You could always just select, but for me, I like to see it next to each other. It just makes it a little bit easier for me to interpret, make sure I'm doing it properly. So I just cut and paste these values here and created this table. In a lab report, I would suggest doing the same. You want to look at your values, make sure they make sense, make sure you have units, and make it easy for other people to interpret your data. So now if we want to put this into a graph, you're going to select this, Control, select this, and then hit Insert, Chart. And it did the kind of chart that I want. So I have reaction rate in oxygen per second on this side. And then I have my temperature values here, and these are the appropriate values. And now I can see my graph. So it gave it a reasonable title. You could always improve upon that title. You can improve upon some of these labels as well. I'm going to go to Customize and see if it will label the data labels. What is this value? Let's see if I could do some more. Numbers, grid lines, will that help me? What's that do? Will it give me more value? Nope. So this is giving me the graph that I want. What I'd really love to be able to figure out is exactly what that point is and have it labeled. We know based on our data that that's going to be 37 because that's where you had your peak, and then from there you went down. Oh, there we go. At 37, it's 0.04791, and which is what we predicted it would be. So here you can see that optimal temperature where the reaction rate peaks, and then you have the enzyme starting to denature as temperatures become higher. Here you have less energy in the system, less likelihood for things to react with each other. So you see the trend that you would expect to see. Hopefully that was helpful. If you have any questions, be sure to ask when you get to class. I'd be happy to help you go through it. Thanks.